Hello, welcome to my YouTube channel. Today is a very special day. I have actually great news regarding the YouTube channel, and I'm super excited because today I'm going to present you one very special piece of hardware. And it's not because maybe it's going to revolutionize the world of computing or graphics cards or workstation or something like that. It's because this product, it was provided by a company in which I really truly believe since I'm a very young engineer. I started working with workstations when I was 16 years old. I went all the way from Mexico, from Monterrey City, back to Chicago, like 2,000 kilometers or something. I traveled just to get a Dell Precision workstation with my first NVIDIA professional quadro graphics cards on it. And since that day, it was already like 16 years ago, I'm working with NVIDIA RTX professional graphics cards in my life. And to be honest, NVIDIA and NVIDIA quadro graphics cards, they literally shape the way I do live until today. Since I was a student of engineering, as a design engineer, a manufacturing engineer, a research scientist in the university here in Germany, my job today as a simulation engineer, a development engineer, and all the things that I made since I was 16 years old, since I first met NVIDIA professional RTX GPUs, it really made the person that I am today. I learned about a lot of software like Solidworks, CATIA, Siemens Unigraphics. I learned Inventor, PTC Creo, ANSYS, Abacus, MATLAB, any software that you can imagine that is related to 3D CAD and 3D modeling, Blender, Rhino, Inventor as I just mentioned, AutoCAD, Revit inclusive back in my days because I had something to do as well with that things. I really believe in GPUs, and I saw the transformation of what we have in personal computing since my first Dell Precision M6400. And I'm very excited today because this company, NVIDIA, reached to me and asked me if I wanted to make a small video reviewing a small graphics card. And this graphics card is the NVIDIA RTX A1000. It's a small form factor GPU, very powerful, very power efficient, and of course I accept it, not because it is something that I get or it's because I really need to something, it's because I really believe in what they do. And of course I'm using this as well with all the work that they are doing in artificial intelligence and everything. But GPUs and power efficiency is one of the main topics since I've been following since like almost 15 years. Always packing more power, making them more efficient, and the NVIDIA RTX Ampere 1000 is a perfect example of it. Very small package, 50 watts, single slot, half height, and incredible performance with ray tracing core, with tensor cores, with tons of CUDA cores, with 8 gigabits of memory. I mean, it's incredible. Multi-display pod monitors and ray tracing capabilities, of course, because of the Ampere generation. And all this, that's what we came in such a small form factor. And I'm very excited because there's a lot of people that they always think that they need a very powerful GPU or that they require like something really huge in order to model data sets and include a lot of data in their memory, which is not really true. I mean, there is a lot of professional, and as well in my way as an IT professional, I provide myself until today all the computational power and workstation that engineers and high performance users need in my company. And they don't need that sometimes yes. But yeah, just to go back to the Ampere 1000 and how incredible it is and the performance that it offers. I don't know if you remember these GPUs. This is like a 10-year-old GPU. This is an NVIDIA Quadro K5000. Take a look to what they come. And this, the Ampere 1000, over the years, it became so much powerful that, I mean, even these GPUs back on those days, they were super power hungry, like 5 times the power requirements. I would say like 10 times the performance less now than this. And that's why I'm very, very interested in such small form factors GPU. Because take a look to what we came. And it is not only about power efficiency and performance, it is about as well how developers actually engineer their computers, like Dell, Lenovo, HP. They develop as well the computer architecture based on the products that other companies offer. In this case, if you NVIDIA offer such a small form factor GPU with great powerful capabilities and features, they tend as well to develop workstations or computers that they are small form factors and they are still very powerful. Maybe even like 1 liter chassis, 2 liter chassis, like now we have with the micro, tiny and mini from HP, Dell and Lenovo. And this is like really a high class and performance GPU. I'm going to be reading you as well the specification of this. This computer has 22 tensor cores and delivers up to 107 teraflops of integer AI performance. And this is like 3 times faster generative AI for stable diffusion process, for example, when you compare it to the previous generation. And the previous generation of these small form factors GPUs is the NVIDIA Turing 1000 or the T1000. I don't know if you remember. It was as well a version with 8 GB out there in the market. Like up to 3 times the performance for generative AI with the same performance, with the same power efficiency. And I mean, it's incredible. And up to 13.2 teraflops of rendering performance, which is incredible. Jorge, who needs this? There is a lot of people out there, like engineers, students, people that work with small 3D models or even with heavy assemblies, that they do not require like to put in an assembly like 5,000 components or something like that. Maybe they develop, maybe something like a microphone, which is small and has maybe 100 components, or maybe they develop something like a mouse, and that's what they do. And to be honest, for that, such a graphics card is going to be more than enough to develop such kind of 3D models. So maybe they work for 3D connection and they develop 3D mouses, or they develop, monitors, small assemblies that do not require that much power, but they are still incredibly important. And you don't need like a 24 gigabytes RAM GPU just to construct them, just to design them and develop them. And those GPUs are more than enough. Maybe you are like a project manager that you are not anymore like developing the models yourself, and you, from time to time you just need to open them, take a look to the measurements and everything, and you have a multi-monitor setup, or maybe you have a 5K display and you need power just to render those images. For those applications, these kind of small GPUs are perfect. Very power efficient and incredible features. I mean, if you use this in SolidWorks, you can develop and design incredible stuff in SolidWorks because you have 8 GB of memory. It has incredible rendering performance. I mean, really, do not underestimate these GPUs. They are so powerful, and we're going to take a look at that later on the video. So let me tell you a little bit more about this. It has 2nd generation ray tracing cores, as was mentioned before. 3rd generation tensor cores is from the Ampere architecture. Don't confuse with the Ada generation architectures. And you will say, Jorge, but this is an old generation GPU. Yes, it's an old generation GPU, but it is from its class, like a small form factor, and from the 1000 series, it's the first of its class. And you will say, Jorge, but we already have like the NVIDIA 2000 and 4000 Ada small form factors. Yes, but they are not single height, they are not half height, they have a bigger cooler, they are a little bit bigger, and they are of course in another price range. Of course, the NVIDIA 4000 Ada small form factor and the 2000 Ada small form factor, they are so much powerful, but first of all, they are so much expensive. They are very expensive in comparison of this. This GPU, you can find it between 4,500 euros or 5,500 US dollars. Maybe a little bit less, depending. Or if you work for a company, probably less. Or if you buy it with a Dell Precision workstation or with an HPC workstation, they are going to be there pretty cheap, or maybe sometimes already including in the price that you are paying for the workstations. It has 8 gigabytes of GPU memory, and it has 7th generation encode and 5th generation decode EMT DEC codecs engines. Sorry. Jorge, what about CUDA cores? CUDA code, incredible, like really. I don't know if you remember the NVIDIA, or when I was in the university, I used to have a Dell Precision 77020 with 2300 CUDA cores and an NVIDIA Quadro P5000 from the Pascal generation GPUs. It was an incredible laptop, super heavy, 17 inches, really powerful, and I did incredible stuff with that GPU in my Dell Precision laptop. And this guy has the same amount of CUDA cores, 2304 CUDA cores, and only requires 50 watts of power. I mean, it's really, really something to talk about it. So, Jorge, thank you very much for the introduction. But what about the design? As I just mentioned, very, very small. I hope you can see here a little bit. Really, really small. 4 mini display pods. That's maybe like a caveat, but when you buy it, you usually get a mini DisplayPort to DisplayPort adapters. Yeah, and very small fan here. You don't need power connectors. It's like really plug and play. Just put it in the PCI Express. It's going to get power from it, and that's pretty much it. I mean, it's really a nice GPU. I just changed my GPU. I have in my workstation. I actually am using an NVIDIA RTX 4500 from the A1000 generation, like incredible monster of a GPU. So I just switched it, and as you can see here now in the video, I just got installed the RTX A1000. This high usage GPU is because I am encoding the video as well with OBS Studio. So let's take a look. I thought I can show you better if I just take you with me to build an assembly. I just download some, I think I have not configured this. Let me configure my 3D mouse pretty quick. So now I just configure this. So I download these models from internet. They're actually pretty cool. Let's install now this one. Let's just add this one. And they are not like easy models, eh? They're actually quite good models. And yeah, this one as well. And then let's just keep adding. Then a gravel bike that I as well downloaded. They are pretty cool models, a lot of components, and I like them a lot. They don't have that much that many constraints, but I think for the purpose of this video is more than enough. So bikes, then road bikes. I don't know why this is like this, but road bike swap. Let me show you here. Of course, I have an i9-3900K, so there's no bottlenecks on CPU with SolidWorks, 128 GB of RAM, and a ton of NVMe storage, 4.0, and of course my A1000. So let's keep adding models. Now let's maybe float them, because otherwise I cannot move them. So this one there, maybe this one here, and then this one can just go front, and then that one stays there. So let's add another bike. I mean, this is just to showcase. I mean, you can download it from internet, and they are pretty cool to use, just to train, to check a little bit stuff, maybe to make some sketches for yourself, and they are actually quite cool. So another component, what do we have as well? Ah yeah, the Scott's pad as well. Yeah, I found it as well a few days ago. Let's open the assembly. This is the one. So it takes a little bit to load all the components into the memory. So now it's there. So now we can float them as well. And now we can take this here, maybe this one here. Yeah, so that's it. Let's save now, rebuild. And the GPU already has 2.7 gigabytes of video memory in use, which that's why actually the 8 gigabytes help a lot. So now let's I think I will want the shadows, it is already in plain white. And as you can see here, there is zero degradation in performance. Like, it works incredible. And this is so much worth it. Maybe you will say, Jorge, you are just rotating stuff that makes totally no sense. But believe me, I work every day with huge assemblies and 3D models in my work. And we have so many difficulties sometimes just because sometimes the performance is not there of our hardware. And we have incredible hardware because I buy it myself, first of all. And we have incredible hardware, like in workstations so similar to the one that I have here, with 14th generation 900Ks CPUs, with ADA and Ampere generation GPUs, incredible memory RAM, but still, sometimes the performance is not there. And if you imagine that such a small GPU as the A1000 can handle all these models, all this information, it's something really incredible. In the past, you couldn't not even imagine with small GPU have so much performance. But that's why actually it's important video cards like the A1000, because they are small form factors and they can do so much more. So that's the case. It has a lot of surfaces. And it can get even better actually if you deactivate the real view graphics, because a lot of people doesn't like the real view graphics. Then, I mean, this GPU gives you so much performance, like literally so much performance. And like this, maybe you can have so much more many things, or I don't know, maybe you're like, okay, I'm going to change something, I'm going to make some sketches there, and of course you can. I mean, there is zero problems to make anything like that. It doesn't matter what, because the power is there and the computer is there, and everything that you want is going to be as well for you there. I mean, I just want to show you. Huh? So it's pretty cool. Let me say that don't change to a frame and discard changing the assemblies. So yeah, that's for SolidWorks. Let's keep this open. Let's open now SolidWorks Visualize. SolidWorks Visualize is the rendering engine now included with SolidWorks, or not included with SolidWorks depending on the license that you have, but is the rendering engine now of SolidWorks. In the past, we used to have PhotoView 360, which was the render engine included in SolidWorks, like in the viewport of SolidWorks. I think since 2021 is not there anymore. But yeah, so now let me maybe open, I don't know, this. Let's take a look. And you will see pretty quick how the memory increases. Yeah, let's just put this like, okay. Hopefully it works. I mean, Visual is quite a heavy program, and I think sometimes I ask too much for my GPUs, but I mean that's why you're there, and that's why you're there, and that's why you are paying actually. So let's take a look. It still doesn't load, so it's still probably getting some information. Now it's loading, and as you can see here now, the memory is ramping up. We can really increase the performance that we require. Let's go to the options. Let's increase the viewport. Now here, see you can see CUDA enabled GPUs, the A1000. Let's mark the auto signal and let's put it maybe like full HD, the viewport. And look, I mean, it's rendering like in real time. And this is something unbelievable, really, really incredible. For a small GPU, no extra power requirements, nothing else. And hey, he's doing his work. I mean, this is pretty cool, actually. And as you can see here now, the memory is really getting full and it's actually working. As you can see, the CUDA cores are just putting there the performance for the rendering. And you don't need to forget that everything is still open here. I mean, it's still everything open here. You can still working on your assemblies if you want. You can just keep adding components, make some sketches. OBS is running in the background as well, so the NVIDIA encoders are working at the same time. And this is where you see how much power and how many features and how important these small form factors graphics cards because they can do incredible multitasking and you will never notice. I don't know, maybe start LibreOffice, for example. You can keep watching YouTube videos, you can keep watching a movie on Netflix. I don't know, you can do a lot of things. Let's open this. This looks nice. Yeah? And everything can be there. You can keep working maybe some small things on Blender as well at the same time. You can use Rhino, you can just keep scrolling PDFs and it offers an incredible performance. I'm just going to show you as well some data. I usually don't show data because I am a scientist of course, but I rely a lot of well-known experience, but I'm going to show you now some data. For example, you probably know the SpecViewPath benchmark, an incredible official benchmark tool just to address the performance of your workstation, of your GPU with professional design software like CATIA, Graphics, PTC, Maya, Solidworks, 3ds Max, so on and so on. It has like 8 benchmark or something. So if you can see here, for SolidWorks, I have few different GPUs. You can see here the information, but we are going to focus on the GPUs now, no CPUs combination or everything like that. As you can see here, the A1000 for SolidWorks in the SpecViewPath 2020 version 3.1, it stays here like 100 and something points, which is pretty cool. The 4500 ADA, for example, it's a very powerful GPU like this, power hungry and everything, but it's very power efficient. It's like a 450, like 4 times the performance of the A1000. But you can say, okay, but that's not that much, to be honest. But you can take a look to the older generation of NVIDIA RTX professional GPUs, and you can see, like, for example, like the Quadro P4000, a desktop CPU requiring like 150 watts of power energy. It has less than double the performance of the A1000. And again, in such a small phantom, very power efficient, like the performance per ratio of power required is really high for the A1000. It offers a lot of performance requiring less energy. And for example, if you put it up aside with his counterparts of older generation Pascal or Maxwell or Turing, it has an incredible bump in performance, which, as I just mentioned, maybe it's not the same like an A4000, even on a laptop GPU, but again, it is a very small form factor GPU. It doesn't require any energy at all, and that's the important things. If you go to CATIA as well, the A1000 places in the middle, like from a T1000 and a P4000, for example, and it offers very good performance for the price, of course, for the price and for the features that it offers. With this, you can do a lot of things like ray tracing, like I don't know, like Blender stuff, and it's going to work incredibly good. So I think that is going to be all for this video. I just want to show you a little bit of SolidWorks with it, and maybe a little bit of SolidWorks Visualize. As you can see here, it's still rendering. I mean, it's still doing his job, which is pretty cool. And I mean, just making this, just doing this and rotating this in SolidWorks Visualize is just really something to talk about it. And as you can see, hey, it's not going to bend the GPU. The GPU, even using 50 watts of power, the A1000 is just going to push and keep pushing, because that's why they are made. They are really professional, reliable 24/7 GPUs. And believe me, in my whole life, since I started with GPU, as I mentioned in the beginning, I never seen an NVIDIA RTX professional GPU or Quadro GPU getting broken. Like, literally, they work. Even this 10 years old NVIDIA Quadro K5000 is still working like a charm. Of course, drivers and everything, but it's still working. I mean, incredible. I never saw something not working, and that's what this is doing. Look at this. The CUDA cards just pushing the NVIDIA encoders as well. The video memory, SolidWorks, like real-time rendering as well, just is working. So guys, as I just mentioned, this is the first video that I kind of got a sponsor. I don't know if I can say sponsor, to be honest, because I'm not getting anything as just the GPU to review. I am not sure if I can get, I'm still actually not sure if I'm going to get to keep this GPU. I don't care, because what I care is to deliver information to you, which is valuable information in some kind of fields that not a lot of people shows you, which is professional 3D modeling software, maybe layered with simulation software. That's what's important for me, and because it is really something incredible for my YouTube channel, because that just only means that probably, and maybe if everything goes correct, I can get you more information with better hardware, with new stuff that is coming out, and I'm really, really excited about it. Because as I just mentioned in every bit of my videos, all this hardware, I buy it myself with my own money. If I buy something like the A1000 generation GPUs, or if I get something used in second Mac of Pascal generation, or if I get a second-hand workstation, doesn't matter if it is 20 euros, it is my own money. And that makes sometimes difficult to get new hardware, because I need to pay for them. I mean, I have my HPC Studio workstation, I have a Dell Precision laptop, I have a Dell XPS laptop, and all those things are coming from my pocket. And this is the first time in my YouTube channel that I get something, at least not paying out from my money. But this is not changed at all, my opinion from it. I'm not getting told to get something like, tell you something that it cannot do. I'm really using them as showing you now. So that's a very important thing to say. I'm not getting paid to say something good about the A1000. I'm just sincerely very happy with the A1000. It packs a lot of performance, a lot of features, very small, power efficient, very good price. I mean, why not? It's a nice GPU. It has a really nice GPU. Maybe for you, it's not the best. Maybe you need something bigger. Maybe you need something smaller. Maybe you can live with an integrated GPU. But for a lot of people, it makes a lot of sense. So guys, thank you very much for watching. Super excited as always, and see you until the next video.